The derivative at a point is the slope of the tangent at that point. The slope basically tells us the rate of change of the output. In this case, a change in the input brings about a corresponding change in the output by the same amount. The ratio of the changes in the output to input values gives us the slope. Since a part of the curve is a straight line, the value of the slope remains the same for all positive input values. The value of the slope remains 1 for the right part of the graph. Now we want to talk about the slope at a point. To do so, we have to make an infinitesimal change in the input in order to bring about a corresponding infinitesimal change in the output. You can consider delta x to be smaller than the smallest number you can imagine. Instead of using delta, we use the letter d to imply an infinitesimal change. We can talk about the slope of the tangent at a point by making dx arbitrarily close to 0. Now we have what we call the derivative at a point. If we approach the origin, the slope of the tangent does not change. So approaching the origin from the right tells us that the slope at the origin is positive, being equal to 1. In this case, no matter how close dx is to 0, the ratio of dy to dx will always be equal to 1. Let's see what happens when we approach the origin from the left. Applying the argument similar to those of the first case, approaching the origin from the left implies that the slope at the origin is negative, being equal to -1. In this case, no matter how close dx is to 0, the ratio of dy to dx will always be equal to -1. So if we approach the origin from the left, the slope becomes -1. But if we approach the origin from the right, the slope becomes 1. Now, in order for the derivative to exist at a point, the value of the slope at that point has to be independent of how we approach that point. Here the slopes approach different values as x approaches 0 from both sides. The sharp edge need not necessarily be at the origin. It can be anywhere on the number plane, such that there exists a value of x for which the derivative does not exist, because the slopes are different at the sharp edge. Despite being a continuous function, it is the sharp edge that brings about the difference in the slopes. No matter how the rest of the curve looks like, the slopes will always be different so long as there is a sharp edge at that point. If we can make the sharp edge go away, the continuous function becomes differentiable at every point in its domain. The derivative exists at the origin since the slopes approach the same value from both sides of the origin. No matter how the continuous function looks like, the slopes will always be the same so long as there is no sharp edge at that point. An introduction of a sharp edge will bring about the non-existence of the derivative at that point.